Hi everyone, just a quick video on the crank position sensor, what it is, what it does and how to test it if you think yours is faulty. I've got two with me today, slightly different looking but the same style of sensor. I know this one's faulty and I know this one works, so when I come to do the test that I want to do, you can see the difference between one that's functioning and the readings of one that is not. So briefly, what is the crank position sensor? Well, as the name suggests, it tells the ECU where the crankshaft is in relation to the engine components. So we've obviously got a flywheel here, and these are the teeth of the starter motor. And on this design, we've got another set of teeth here. This is for the crank position sensor. So the crank position sensor itself has a little coil inside, and it generates an electromagnetic field on the outside here. So it's what we call a passive sensor. It creates, as I put on the board there, creates its own AC voltage. So what happens is it sits here above these teeth, and as the flywheel spins around with the position reluctant ring on it, it's effectively counting the teeth. So every time one of those teeth goes through the magnetic field, it disturbs it and it creates a back voltage to the ECU. So we end up with a waveform like this, which is called a sine wave. If you'll notice on here, there's a tooth missing, and that's intentional. That's the reference point. So that would normally line up with piston number 1 at top dead center. So the ECU will convert it to binary. So we've got ones and zeros. So a high point might be a 1 and a low point might be a 0. And then as it comes along here, it'll end up with a double 0. The ECU will then know that piston number 1's at top dead center, and then it can work on the fuel and the ignition timing based on that. So briefly, that's what it does. It sits there like so, counting teeth and knowing where the reference point is. So how are we going to test them? Well, first of all, I'm going to test the one that works. There's two tests that we're going to do. We're going to test it for resistance, so how much resistance is in here, and all it's doing is testing whether the circuit's complete in there. And then we're going to do a voltage test. Because it's a AC voltage system, it generates its own voltage, so we can test that voltage that it's creating with the multimeter. So I've got my multimeter here. The two settings I'm going to use are this voltage one here with a wiggly line. That's AC voltage as opposed to DC when you do batteries. And this omega sign here, which is your resistance sign. So first I'm going to do the resistance test. I'm going to pop it on there, hopefully you can still see it. And as I can put on the board there, the resistance is up to 2,500 ohms. It's quite a large range because obviously there's a lot of different systems out there. So very briefly, most of them have two contacts. So all I'm going to do is put my two crocodile clips and my two leads onto there and check the resistance. Make sure they're on correctly, which they now are. So it's 415 ohms of resistance. So all that's telling me is the circuit inside there is complete. It's generating a resistance, so there's no wiring faults within there. Again, up to 2,500 ohms is possible, so we know resistance wise that's okay. So all I'm going to do now is remove it to the AC voltage setting down here, and then we're going to put it onto here, something that's magnetic, and I'm going to bounce it up and down just to disturb the magnetic field on it. Again, as you can see, 0 to 1 volts possible. This is on millivolts, so points of a volt. So as you can see, it's jumping around 100, 200 millivolts, so 0.1 or 0.2 of a volt, which is acceptable. But the main thing that I'm looking for is it reacting and is it changing resistance, which it is. So I can confirm through those two tests that this crank position sensor is working correctly. So I've got the other one here that I know is not working. I've just tested it earlier, and because it's a plug, what I've done is got these two knitting T-pins here just to plug into it to make sure I'm getting to the electronic connections. I'm going to do the same tests, but I'm going to be expecting different readings here. Okay, so first thing I'm going to do is the voltage test, which I'm still on the setting for. So just clamp one on there, make sure that the contact's not touching each other, because that'll give us a false reading. And then the other one there, those two are not now touching each other. So if I put it against the reluctant ring again, it's generating me a voltage similar to the previous one. But the difference with this one is that if I turn it to resistance now, open loop. So that is actually an open circuit. So in this particular one, the coil's still working. It's actually generating voltage, but it's not actually escaping from here and going up to the ECU. Or there's enough resistance in here to mean that the ECU is not receiving a large enough valid signal to actually respond to it. So for me, what's happening in here is the coil is working, but there's some sort of wiring fault on the connector all the way up through here and possibly through here as well. So it's actually open circuit, and you can see it just tripped on and off then. So there's obviously, it is working to some degree, but as you can see, as I'm flicking that wire in, it works, then it goes open loop. So the wiring itself is at fault here rather than the sensor itself, but the effect's going to be the same. The engine management system is not going to know the engine position, therefore probably going to go in limp mode. So that's how we test it. So test it for resistance and test it for AC voltage to make sure it's generating voltage. If both of them are giving a decent reading and it's responding to the magnetic field being changed, it's good. If you're getting open loop or open circuit on the resistance, or it's dropping in and out like this one is, then you know you've got a problem with the circuit itself. And again, if you're getting no AC voltage, then you know the actual coil itself inside's failed. I hope that makes sense, and I'll see you in the next one.